Hello, ladies and gentlemen, and welcome back. Welcome back. We're looking in this video at question 23 from our 2011 Pascal contest. An ordered list of four numbers is called a quadruple. A quadruple PQRS of integers, all non-negative, is chosen at random so that it satisfies 2p plus q plus r plus s is 4. What is the probability that p, q, r, and s is 3? Okay, two very similar looking expressions. The first thing that jumps out at me is, okay, we know 2p plus q plus r plus s is 4. That's given. If we then also have that p plus q plus r plus s is 3, if I take the two equations and subtract them, the q's cancel out, the r's cancel out, the s's cancel out. 4 minus 3 is 1. 2p minus p is p. So we just need p to be equal to 1. As soon as if you can get 2p plus q plus r plus s to be 4, and you get p is equal to 1, then you definitely have the answer. So they're asking for probability in the question. How do you do probability? Well, you count up the number of ways you get something specific that you're interested in, like p plus q plus r plus s is 3, or as we've just shown, number of ways to satisfy this first equation with p equal to 1, and you divide by the number of ways to satisfy this equation in the first place. So how many ways can I pick my p, q, r, and s to get a sum of 4? Okay? And I want to pay special attention to the p values. Maybe break it down into cases based on p, and one of those should be p equals 1. Okay? Well, if we're focusing on p for a moment, p could be 0. That's fine, and then q, r, and s make up 4. P could be 1. For example, 2 times 1, q is 2, and then r and s are 0. That would be fine. You're allowed to have zeros, you just can't have negatives. P could be 2, and then everything else is 0. And that's really it. If p is 3, you get 6. And the sum of these numbers can't be negative, so that's already too much. So we've got some casework ahead of us. Let's take a look at maybe p equals 2. Well, if p equals 2, 2p is already 4. So q must be equal to r, must be equal to s, must be equal to 0. So there's one way to get a sum of 4 here. Okay, one way, that's fine. What if p is equal to 1? Well, then 2p would be equal to 2. So what do we need? We need q plus r plus s to be equal to 2. How many ways are there to do that with all these numbers being non-negative? Oh, this shouldn't be a p, this should be a q. Okay. Well, for example, you could get q to be 2, and then r and s are 0. And I suppose you could have r is 2, and then q and s are 0. Or you could have s is 2, q and r are 0. So that's 3 ways. Okay. But you don't have to have that. You can have 2 of the numbers be equal to 1 and the other number be 0. How many ways are to do that? Well, there's 3 numbers here. So we've got 3 choices as to which number is 0 and make the other 2 numbers 1. So that's another 3 ways. Don't have to write them all out. Okay. So there's 6 ways with p equals 1 to get 2p plus q plus r plus s equal to 4. Now what if p is equal to 0? Well, then 2p is 0. And so I need q plus r plus s to be equal to 4 all by itself. So what could we have? Well, we could have one of these 3 numbers be 4, and the other 2 numbers equal to 0. There's 3 ways to do that. There's 3 ways to choose the number that is equal to 4, and the other 2 are 0. So that's 3 ways. What else could we have? Well, maybe q is 3. So there's 3 ways to pick our number that's 3, and then there's 2 numbers left over. One of them's got to be 1, the other one's got to be 0. There's 2 ways to pick the number that you didn't pick to be 3 to be 1. So that gives me 6 different ways. Maybe q is 2. And then you could have another one of the numbers be 2, and then the final number be 0. There's 3 ways to do that. 3 ways to pick which one's going to be 0 and make the other 2 2. Or Q could be 2, and then the other numbers are 1. Again, 3 ways to do that. Pick the number that's going to be 2. There's 1, 2, 3 ways to do that. And then the other two numbers automatically are 1. So that gives me a number. We're going to have to flip over to the other side. What if Q is equal to 1? Right? Well, you could say, all right, maybe R is 3 and S is 0, but you'll notice that we already have that covered. Okay? We don't want to do what's called double counting. We don't want to count the same thing, the same case twice, and we would be counting that same case twice. Okay? So what you might do is say, just assume Q is bigger than R is bigger than S in order to sort yourself out. But it turns out that these are really the only cases you're going to have. Because as soon as Q is 1, something's got to be at least 2, and then you're back to one of these other cases here. Okay? So that gives me 3, 6, 3, 3. That's 15 cases in total. So the probability we seek, we want the number of ways with P equals 1 on top, so that would be 6. And then 1 way with P equals 2, 6 ways with P equals 1, and then 15 ways that we just worked out with P equals 0. So that'll be 6 out of 22. We can simplify that to 3 out of 11. Okay? So 3 out of 11, and that's going to give me an answer of B. Okay? So fantastic. Just want to make sure, one way to do it with P equals 2, that makes sense. One way to do it with P equals 1, that's fine. Just don't want to overlap. No, that's a separate case from that, or that, or that. So it looks like we're good to go. Everything's fine. Okay, so that's all there is to it. And I guess up next will be question number 24. I'll see you for that in the following video. Take care.